Assalamualaikum warahmatullahi wabarakatuh and very good morning. Today I'm going to present my project assessing upper limb performance using rehabilitation and assessment device, ReHAD. Okay, so this is my team member. So according to WHO, so you can see around the world, so including the developing country, worldwide is about 15 million people suffer from strokes worldwide each year. So it's equal to 1 minute is equal to 28 people will have a stroke. This number is very heavy. Okay. So in our health DG, Malaysia Health Technology, mentioned that in 2040, 1 in 4 Malaysians estimated to suffer from stroke. So you can see from here is 150 out of 100,000 Malaysians suffer from stroke with an average daily hospitalization of 92 cases. Okay. So, and then it's about 32 deaths every day due to stroke. So this number is very scary. Okay. So then we go to we do a market survey. Okay. We go to the rehabilitation center, general hospital, and then a private hospital. So we found out that there is a large number of patients and large number of physiotherapy. So in Malaysia, so currently the ratio is not equivalent. Okay, so you can see that one physiotherapy need to cover to up to 35,000 stroke patients. So the optimum is only 14. Okay, so what happens when there is a large number of patients and lack of physiotherapy? So group therapies will be conducted. So this kind of session is not effective. So this is the effective way. It is one-to-one. However, the time is very limited. So it can cover up to 1 hour only per patient. We try to look at the current rehabilitation robot. So there is the several robot for reaching, for manipulation, and robot for reaching and manipulation. So what we found out that there is a limitation where the design is complex. Some of the degree of freedom are missing and also separately assessed. Okay, and then the cost is very high. Okay, besides the predictive model, the assessment model, the accuracy is very low. Besides, it requires high supervision. Okay, then we tried to do a study. For activity daily living. We found out that when we do, for example, the drinking movement or pick and place, we found out that our movement actually is very confined to a plane. Okay, very confined to a plane. Okay, a specific plane. For example, we want to take a pick and place. We want to take something in front of us. Our movement is just a straight line. Okay, so we look at the several angles. We found that the movement is actually is very straight line. Okay, then we can simplify the design from the exoskeleton, the very complex design, to the simple design. So we just use the linear movement only. So we can change the direction. So whatever we want to improve our hand. Then we can change the handle. Okay, and then this is how we can simplify the design. Okay, so this we come out with the ReHAD, rehabilitation and assessment device. So where this device actually can do several movement. Okay, this device also can do an objective assessment with heartbeat monitoring, and then it include the virtual reality games, and it can change the handles, and also can do a multiple setup for standing and sitting. Okay, so this is a product features. So the device can move, can rotate the hand for arm rotation, can train for arm rotation, and then for reaching, forward and backward movement, and also the grasping. Okay, so this is a product feature. So this feature is an experiment setup. Okay, so I will explain the assessment, training, and video feedback. So this is the assessment. So we have a draw eye, draw diamond, and draw circle. So this is isolated movement. Okay, and this is a linear combination movement, and this is a non-linear combination movement. Okay, so this device also can measure the range of motion for reaching and for pronation and supination, and also the grip strength. Okay, and then we can also do a specific training, for example, the reaching only, and then for pronation and supination, which is the forearm rotation only, and also for grasping only, okay? And then we can also do the combination training. So we have a easy, so this is easy, so patient can move whatever they want, wherever they want, as long as they can reach the target, and then they can also follow the path, specific path. So once they are finished the training, they can get the immediate feedback. So what is their performance, okay? So either excellent, good, or poor. So this is kinematic variables. It's very important to measure the performance. So what is the novelty? So the novelty is actually the device itself. We simplify the design to simple and compact rehabilitation device. And then the second one is our robotic assessment module, which is the game. Okay, the system. And then our algorithm, our predictive or assessing module, this is very high, higher accuracy in assessing stroke hand function performance. So we brought this device, we meet several person, okay, the NASAM consultant, the rehab manager, even the medical doctor. So they give a very positive feedback. So some of them mentioned that this device can also proceed to the gross movement, but can also can train the confined movement. And then we also do a clinical study. Okay, we do a clinical study at NASAM. So actually this is our first version. Okay, our first version of the device is the IRS, and this is the second version, our second version or improved version of the design. So we conducted a study at Picasso. We reached about more than 50 stroke patients actually. So we found out that the device improved a lot from our previous version. Okay, the accuracy is about 98%. So that we can predict the clinical scales. Okay, so this is the feedback from the patients. So most of them like the device, and yeah, they say they feel comfortable and not feel fatigue.
This device is manual, technology assisted, but manual operated by the patients. So sebenarnya saya as trainer ataupun as occupational therapist, saya memang lagi suka yang manual operated, because dari segi research, in clinical research, manual operated devices ni dia beri lebih impact pada rehabilitation untuk stroke patients. Dia lebih membantu dari segi hand rehabilitation. So bila manual operated device dia ada sedikit, maksudnya macam games kan, so lebih interaktif. So lebih seronok lah untuk patients buat.
Okay, so what is the benefit? So from the conventional assessment, okay, so we compare the robotic and also the conventional. So for a patient, so in conventional assessment, the assessment is very less interactive and also very high supervision. So by using our device, the device is more interactive. We have a feedback and feel motivated. Okay, so the patient want to participate to the training, okay, and also the assessment. So for the therapies, so for the conventionally the form, okay, the form is very subjective. Okay, the scoring is very subjective and highly depending on the experienced therapies. So by using the device, patient actually play the device and then get the assessment very accurate. So this device assists the therapy, quick assessment, and very accurate, more accurate score. So what is the uniqueness of this device compared to others? So the others device is very huge, complex, and expensive. So our target is to sell maybe around 5,000 ringgit. So this is a portable, affordable, quick assessment, including the hand movement and also the strength. Okay, so this is the global market for the robot rehabilitation robot in comparison 2021 to 2028. Very high. It's about 3,000 million, okay, USD in 2028. Okay, so our market potential, for example, in Malaysia, we take the 55 medical center and plus with the 20,000 stroke survivor each year, and we assume that 70% from them will buy or rent this device, and the market is around 0.1 billion. And worldwide, we take the 55,500 medical center for rehabilitation, plus with the 60 6.3 million stroke survivors each year. So, and we also assume 70% from them will buy or rent. We found out the market potential or market size is around 31.8 billion ringgit this year. Okay, so what is our strategy to commercialize? So we developed two devices. Okay, one the first version is IRES, and then now is ReHAD. We improved, and then we already do a clinical pilot study or a clinical study, and then we want to reach more patients. How to get more patients to test the device? We will go to the rehab center, general hospital, and also the private hospital. So ReHAD has the potential to be commercialized and rented to the stroke patient who want to undergo a self-rehabilitation program due to its compactness and portability, only needing PC to use. So this is our collaborator and support. So we have as academic, we collaborate with the UTM, and for the industrial, we collaborate with the Tech Care Innovation. So this is our support. Okay, so NASA and also DF Automation. So we started the project is in 2014, okay, by developing the first version, which is we named it as IRES. So we proved that only by using a 3 degree of freedom, we can do assessment and training for the patient. And then we do a pilot study, and alhamdulillah, we proved that 3 degree of freedom is enough, okay, and has a potential to train and assess the patient. So now in 2019, we improved the design. So from the feedback we can see the bugs and everything. We try to improve. We develop a ReHAD, okay, including the machine learning. So now we implement the machine learning to the device. So we found out the accuracy is improved up to 96%. Okay, so we target by 2025 we have a full complete system. Okay, so we have the device itself, the GUI. Also, we already reached more than 500% subject per patient, and we plan to commercialize it. So this research is funded by the MOHI through the RESA grant and internal education grant, and we also get the ethical approval from UTHM itself, and we also have approval from NASAM and also from the Perkeso to undergo the study to collect the data over there. And for now, we have IP copyright, okay, so copyrighted for development of rehabilitation and assessment device for hand reaching and manipulation. And then we submitted the other were linear and non-linear predictive model. We already submitted the copyright, and we also will submit another one, which is the hybrid. Okay, the hybrid, the combination linear and non-linear. We will submit after this. Okay, so this is our 10th publication. Okay, so in several journals.
These are the medals that we won before. So all of them, we got a gold medal in a different competition in 2016, 17 until 2021.
And this is our references. And lastly, we really hope that this device can be a faster track toward the recovery. Okay, that's all for me. Thank you. Really please refer to our support document for more information. Thank you. Assalamualaikum.